Welcome to your MOOCs course, Internet of Things, Design Concepts and Use Cases. In today's study, we are going to talk about ESP8266 module. When we talk about Internet of Things concepts, it means you need to send data from sensors to the internet. Till now, we have interfaced variety of sensors, but we were able to see data either on the serial monitor or on the LCD board. So when we talk about sending data online, it means you need a gateway module. And there are plenty of gateway modules in the market that you can utilize with your Arduino Uno board. One of the simplest thing that you can try is ESP8266 Wi-Fi module, and the same we are going to interface today. Right on your screen, you can see the pin diagram of ESP module. You can see here we have 8 different pins. The first one we can see is a VCC pin that you have on pin number 8, the most important one, and then we have the ground pin on pin number 1. So these two you need to connect to the ground as well as 3.3 volt of your Arduino board. Along with this, we have a channel enable pin which is always connected to the same supply as that of your VCC module. So we can connect this channel enable means pin number 4 again to 3.3 volt. After this, we have the transmit and receive pin. So we'll be using these transmit and receive pins to receive and send data through your Arduino board, and we'll be communicating with the internet through this gateway. So it means that on your this 8-pin device, which is ESP8266 module, we will be utilizing 5 different pins. Other than this, we have GPIO 0 and GPIO 2 pin that will keep empty, and along with this, the reset pin will also not connect. So out of all 8 pins, 3 pins will be unutilized and 5 pins we are going to connect with the Arduino board. So first of all, let us make the connections on the hardware side. I have this ESP8266 module in my hand, and on the back side of this module, you will see the pin names are printed. When you buy this module in the market, you will find it in 2 different versions. Some of the modules have the pin description written on the back side of the module itself. And for some other modules designed by different companies, they may not have pin description on the background. But in both cases, you can follow the same diagram that you have seen on the screen right before. So following the same description, I'll be connecting these wires on the Arduino board respectively. So as we always know that the first pin we connect is the ground pin, and we'll be using it on your Arduino board. So I'll just pick up this black wire which I have connected to the ground pin right now, and I'll be inserting it on the ground pin of Arduino board. Similarly, we need 3.3 volt connection. But recently I told you that we need 3.3 volt connection on 2 different pins. And the problem with your Arduino Uno board is that we have only one 3.3 volt connection here. So what we can do is, we can take one extension from Arduino Uno to your breadboard, same as I have done with this orange wire, from 3.3 volt to a common VCC connection on your breadboard. And now I can use both my VCC and channel enable connection through this common circuit. So I'll simply take this VCC wire and insert it in the same combination of wires, and then we are going to take your channel enable pin and inserting it in the same series of holes. Now I'm left with transmit and receive wires that we have to connect on the transmit and receive wires available on the Arduino board. The 0 pin on this digital port is your receive pin, and 1 pin is your transmit pin. So here is one interesting concept that you need to learn. When we are interfacing ESP8266 module with a manual AT command based interface that I will demonstrate you soon after connections. We connect a receive wire of this module to receive pin of Arduino. Similarly, transmit wire of this module to transmit pin of Arduino. Remember this, the same module pin connection we do for manual commands. But after doing manual commands, we will be using it through a software code. And in that case, you always use these wires interchangeably. It means receive wire from your ESP module will be connected to transmit pin of your Arduino, and the transmit wire of your ESP module will be connected to the receive pin of Arduino board. That completes your communication network. Means when we are sending something from one end, it works as a receiver, and we are transmitting it to other end, so it works as a transmitter. So the same connection will be following with a software code to send data from a sensor to the online platform. So I will be inserting first the direct connections. So I am going to pick one of these, that is your transmit pin, and connecting it on pin number 1 on digital port of Arduino. Similarly, the one remaining connection that we have for the receive pin, I will be inserting it on the 0th pin of digital port. So this completes our hardware connection. And now I need to connect the USB board, and then we can just see the interface. So I am taking up the USB wire and inserting it here, and we can see your Arduino is turning on now. After this, I will be switching to the software terminal, which is Arduino IDE. Since I told you that in the first instance we will be making manual use of commands, and in order to interface ESP8266 Wi-Fi module, we need AT commands. Why we call them AT commands? Because they have the sequence AT. Capital A and capital T will be used throughout the command system, and I will demonstrate you several commands that you can use to configure your 8266 module. Before we start configuring, the first step you have to follow is you need to go to your Arduino IDE platform and go to the file section. Click on the file section and then go to preferences. So we will click on this and you will see one new window here. In this window, you have to insert this specific link. This link will be also available in your support content when you will learn through this video. So this link you can copy from the support content, and then you have to paste it inside this box, which is your additional boards manager's URL. Once you insert this link into the prescribed box, you have to click on OK, and then your board will be soon installed automatically on the system. After this, we can close your Arduino interface and we will open it up again as a new sketch. Once it is reloaded, we can start our interface further. So now what we can do next is, I will go to the tool section, I will just ensure that COM port is right as well as your Arduino board is selected, and after this I will just upload this empty code on my Arduino board. Now you may have a query that why we are uploading an empty code to Arduino board. This is just because we need to erase any existing program that may be available on your Arduino board, so that it has the fresh availability for intercepting your AT commands. So in order to do that, I am just clicking on the upload here, and soon after this your code will be uploaded on the board. We are seeing here compiling sketch and then upload, and it says done uploading. Now we are ready to open up the serial monitor and we will start with the interface. Make sure that your baud rate is selected to 115200 for this manual interface. So I have selected it on the same level, and at the same time this both NL and CR settings must be activated. After this, we have to go to this top editable window, and there is a send option we can find. This particular send option will be using to send 80 commands from the monitor to your Arduino board, and it will further interface with ESP board. So what I will be doing here is, I am opening up a set of 80 commands here that I will be using one by one, and I will be explaining them to you that how they are working with your ESP board. First of all, we have this simple 80 command that I will be just inserting here and press enter. You can see your ESP board says OK. It means your connection is ready and it is responding OK as a response to your 80 command. Now we are ready to interface remaining commands to check initial configuration of your module. So starting with this, the first command I will be using is 80 plus GMR. This is just to check version of your ESP module. If I run it, it will display all information about version of your board. Next, we can reset your ESP module. So 80 plus RST command can be used for this. Make sure you insert all these commands in capital letters, and there should be no unwanted space while entering these commands. So that precaution you have to make every time. You can see that it says your tool is ready. And after this, we can start checking the mode of your ESP board. This ESP gateway works in 3 different modes. One mode is your station mode, second mode is your access point mode, and third mode is a combination of station and access point mode. Currently, we are going to use it in mode 1, which is station mode, and that will be the preferred mode whenever you are sending data from the hardware to the software. So I am using here first a mode test. So it is with the command 80 plus CW mode and a question mark, since we are asking ESP module to tell its current mode status. So if I insert this, it says mode 1, which is our desired mode. In case if you buy a new ESP module and chances are that it is not preset into mode 1, in that case you can change its mode by utilizing the next command, which is 80 plus CW mode equal to 1, and it will immediately set your mode into desired version. So this command currently I am skipping because I have already the mode of the ESP board into 1. After this, we can check for all available Wi-Fi connections in the surrounding, and for this we have 80 plus CW lab command. If I run this, we can soon see a list of Wi-Fi connections that are available around, as you can see right now on my screen. So based on these connections, now you can choose your next connection that you want to insert for your ESP module. There is one important concept that you need to learn, that if you connect your ESP module with a Wi-Fi which is firewall protected, it will not work directly. So you need a open Wi-Fi in this case. So in my case, when I am demonstrating this, I will be using a Wi-Fi from my mobile phone itself. So I will just be using your settings for Wi-Fi hotspot here, and after this I will be able to connect it with my chip. So as soon as your system is connected with the Wi-Fi, we can start communicating with the mode here. So I will be testing once again the CW lab connections, inserting it here and making sure that I can see my connection code here. So I can see my SSID right now, means I can connect to this SSID. So after this, we have the next set of command, which includes your password and SSID. So whenever you have a open Wi-Fi connection available in your surrounding, you can insert its SSID and password in the same format as you can see on the screen without using any unwanted spaces. In case if your SSID name already have some spaces, some dots, etc., or any other symbol, you have to use it as it is, but otherwise no unwanted spaces. So let me just run this command and it will soon show you details about connected Wi-Fi. So it says Wi-Fi connected at IP obtained and it replies OK. So we are ready with your Wi-Fi connection now. So after this, we are again going to run a few set of commands. First is to ensure a single channel communication. I am running this and it replies OK. After this, I am inserting a API address of ThingSpeak platform. ThingSpeak is the server that I will be utilizing to send data online. I will be explaining this on the website as well. Currently, I am using the API address of that particular website where I will be sending my data from this hardware to see on the cloud interface. Either you can use the IP address of this website or you can simply use API address. So both these commands can be utilized alternatively. And after this, I will be deciding the packet size. So I will be inserting it here, and after this we need your channel ID. I will be explaining this channel ID and field ID information to you soon. And we have send data, and after this we need to close your packet. So I am inserting it here and it says send OK. This is the first description you need to see. And now I will be explaining you different things that we had in this code. The first important thing, the API address. This will be common in case of ThingSpeak website, which is a freely available source that can be utilized by any of you, or all your students can connect with a simple Gmail account on this particular website. Let me show you the website. We have this website ThingSpeak, available as a free user interface as well as with subscription version. So when you start as a free user, you can create 4 different data channels on this, and those channels allow you to monitor 8 parameters each. So when you are designing a specific hardware system, you can insert your all parameters into specific channels out there. For example, temperature, humidity, some gases, all parameters readings you can take in your channels. And this platform also allow you to have on the platform MATLAB integration. So when you have obtained data from certain hardware and you want to integrate it further with a MATLAB platform for visualization, you can do that directly on the website. So in order to do this, first of all, I have logged in with my Gmail account. You all need to create a login and then you will be able to create new channels here. And then we can go to the channel section, and here I have my channels option. In my case, I have already created 4 different channels. But in your case, you can first go to the new channel and then insert some reliable information. So as a free user, you can create these 4 channels here. What details you will have in each channel includes these channel settings: name of your channel and field details, for example, temperature, humidity, moisture level, CO2, whatever parameters you need to measure, you can just insert name of those parameters in the field IDs. Currently, I am going to use this existing channel for testing my ESP gateway connection. And in order to send data to this particular channel, you need its API keys. What are API keys? They help you to read and write data to a certain cloud platform. For instance, we can go to API keys section here, and here we have read and write API keys. You will have unique API key for your channel, and when you are working on a project, you need not to share these read write keys with anybody, because these are secret keys of your channel and they must be useful to the candidate only. Once you want to make your channel ID public, then you can share your IDs easily, or you can make your channel public as well. But preferably try to keep them secret so that you can send data to the channel only. Currently, because I need to send data to this channel, it means I will be writing data to this particular channel. So I need to use write API key. So this will be my write API key, and you might have observed that the same key I have utilized here in this code. This is the same key as that of your channel API key, because I will be sending data to this particular channel. At the same time, you will see here I have written field ID is field 1. It means that for different settings of your channel, like we have 8 different parameters, I will be using this first field. So, I am sending some random data to this first field right now. If you want to use any other field, you can change the text here. It will be field 2, field 3, field 4 or any of the 8 fields available. And you can turn them on and off by just clicking on these tick marks. So, getting back to your view of the channel, it says the last data we have received 4 minutes ago, the recent one that I sent here, we can see here. Similarly, if you enter new data bytes, they will be transferred to your software window. So, there is one important observation you have to make. When you are inserting these 80 commands on your serial monitor, you need to insert them with a very fast switching, because if you delay between one command to other, your connection will be lost in between. So, that is an important thing in case of manual. You need not to delay your command insertion. So, for instance, once you have entered all the commands, then you can go to the writable section and you can use up down keys from your keyboard itself to insert your new commands, and it will help you to insert any of the data on your system. So, let me send one more data for instance. First, I will be using my ThingSpeak address. So, inserting this, and then I will be utilizing your CIP send command, which is the packet address, packet size. So, 51 bytes basically we are trying to send, and then we have the field details. For example, the byte I want to send is value 200. So, I have inserted the same, and then we have CIP close. So, this means your value 200, a random value that I picked in my code, is sent to the channel here, and it says it received data less than a minute ago, and the entry we can see here 200, because this is a random entry I made, but we can see this on the screen right now. This is the first section with the hardware interface. But once you have configured it with the manual commands, you are ready to use it with the software, and now it is pretty easy, because I can show you a software window here. Whatever we have inserted with manual commands, now I have compiled all those things using a software code here. Let us see this code first of all. I have a serial library here which we require for transmit and receive communication, which is a serial communication here. So, we need this software serial library whenever we have communication over transmit and receive line. Then we have credentials of your Wi-Fi system as well as your API keys. Then I have inserted IP address of my ThingSpeak platform. You can even use API or IP, any of these. Then a variable send value, any random variable you can use instead of this. Then in the setup section, I have serial begin and then print command 80 and OK. If it gets response from your ESP board, OK will be printing here. And then I have CW mode, this command also we have used. Then I have 80 plus CW JAP, which is to set your SSID and password for Wi-Fi. So, the same I have inserted here, and then we have printed here the CMD sequence, that yes, we have received the content and Wi-Fi connection is ready, and it will display OK after this. So, the same manual commands now I have used in the code itself. After this, we have the loop section where we have a random function. It will automatically pick any random value from 0 to 1000, and it will try to send it online on your ThingSpeak platform depending upon which channel and field you have utilized in the declaration. Then we are sending this value with a delay of 50,000, which is a millisecond range we have created, 50,000 milliseconds. And then we have the CIP start sequence that I have shown you manually as well, and this includes your IP address which we have declared in the beginning, and then we have the port address of your ThingSpeak platform, which will always be 80. This is the specific port address of ThingSpeak. Then a small delay again, and this last segment is to send your data, your specific string to the field 1. So, I have mentioned here that I want to send data to field 1, you can change the field again. So now we are interfacing it with the code directly. I'll be just inserting this code on the hardware and it should start the same interface without any manual AT command. But there is one simple change in the hardware that you need to make, which will be just interchanging your transmit and receive wire on the hardware side. So I'll be first taking out this USB port, and then I'm just taking out both these wires and interchanging them, means transmit to receive and receive to transmit connection I'll be making here. So that will be your connection when you are using the software code based commands. And there is one more thing, I'm just inserting the USB board. When you start uploading data to the Arduino board with transmit and receive connection, every time you need to take care of one thing here. If you connect these wires in advance and then try to upload your code, you will get an error. That is always a case. So in order to avoid that upload error, what you have to do is take out these wires for a while, simply take them out, then upload your code. Check your tools, check your port, and then click on upload button. Wait while it uploads on the Arduino board. So we'll just wait for the compilation and then uploading, and it says done uploading. After this, insert these wires back to your transmit and receive pins here and press this reset button to refresh all your connections and code here. It will be ready after this. You need not to do anything, just insert wires back. And now we'll get back to your serial monitor and we can see all the data right here. So you can see it is currently sending a random value, and if I just refresh everything, it will display everything in detail. We have the Wi-Fi connection, we have the value details, and depending upon how much delay we have added in milliseconds, it will send this 807 value to your ThingSpeak channel 1 with field ID provided in your coding sequence. So we may need to wait just for few seconds here and your data will be sent from here. In the meanwhile, what you need to check, you always need to make sure your 16-digit API address is right so that it goes to the right channel on your ThingSpeak account. Similarly, the field ID, you have to be very much sure that you are sending it to field 1, 2 or 3, whichever you have used at a time. This is when you are sending only one value. After this, I will be sending data from the sensor itself, and while working with the sensor, you just have values depending upon the sensor outputs. So the same thing you will see further in a case study based interface with air pollution monitoring, where we will be sending multiple data, multiple sensor data to the ThingSpeak platform. But currently I will be using it just with one sensor to boost your understanding on the concept. So I can open up this and you can see it has sent data to your channel ID here, and we can observe it on the ThingSpeak platform as well. It says less than a minute ago, and this is the latest reading 807 that we have received. Means the second level test also we have connected, and now we have the final stage, which is very simple for any of you now because you have already interfaced DHT11 sensor. So you already know how it works. I'll just make a simple connection. First I'll take my VCC wire from your DHT11, and as we know this works on 5 volt. So I'll be inserting it into the 5 volt here. Then we have the ground pin, the last one we have. I'll be using the ground connection from any of these or from here as well, or then we have the middle wire as your data line. So we'll be using it on any of the pins on your digital port here. Only 3 connections we have made. And now a simple code for this thing. The same sequence as we have seen recently, but just with the addition of DHT sensor. What we have in this, your DHT sensor library, then I have one additional library to support macros and functions or additional subroutines here. Then we have software serial library that we have already discussed. After this, this section is optional. If you want to connect your ESP module on any other pins except transmit and receive, you can declare them here. Otherwise, I have kept this in comments. Then we have declaration for the DHT sensor, this we have already discussed. Then we have the Wi-Fi credentials that I have inserted here. Then we have the channel details as well as API keys or ThingSpeak details we have updated here. This section is about your AT command reception on the ESP board along with the baud rate setting. And then we have the loop section. First we are reading data from the temperature, humidity of your DHT sensor module. We are displaying it on the serial monitor by using serial.print command that we have already discussed. Then I have added a delay of 150000. When you are sending data from the sensors, it always require more delay depending upon how big byte construction it has to do. So it will be basically creating a packet of all the data bits that it is getting from the sensor, and it takes time to create that packet. So we need to increase delay depending upon how many sensors we have connected. Sometimes you create every part of your hardware, your code as well, and you will see data on the serial monitor, but you do not get data on the ThingSpeak platform. Reason being, the delay here is very less. So you need to increase delay in that case so that the packet is formed and then it is received on the channel itself. After this, I have created a subroutine which is to update temporary values, and inside this I have all my field details. You can see the CIP start command we have already discussed, IP address it can take from the existing declaration, port ID we have provided here, and then on the field 1 I am updating temperature, on field 2 I am updating humidity from the variables that we already used, and ultimately we are sending the packet to the ThingSpeak platform, and this section just closes your packet over there. And ultimately we have connect Wi-Fi subroutine. I have just segregated it into different sections here to make code cleaner. So connect Wi-Fi subroutine first creates a station mode with CW mode equal to 1. Then we have AT plus CW JAP command to connect with your SSID and password, which it can take from this command section, and ultimately we are pressing OK if your data send operation is done. So this is your entire set of code which we can now interface with this already connected hardware. So I am inserting USB cable again, and before uploading your code, we know what setting we have to apply. First I need to take out these two wires. That is always necessary when you are working on transmit and receive lines. And after this I just need to select my board as well as port here, and I can click on upload button. Making sure that you connect receive and transmit wires alternatively whenever you are sending data from sensor to the ThingSpeak platform. So currently it is uploading your code and it says done uploading, and I am inserting wires back to my transmit and receive, making sure it is oppositely connected on the module itself. And we can click on the reset button here to refresh all the connections as well as code, and now we are ready to see details on the serial monitor. So I am opening your serial monitor here, and we can one by one see all the code outcomes. So it starts with the AT command, then we have CW mode equal to 1, the Wi-Fi connections are ready, and also we can see reading from DHT sensor. With a delay of few seconds, it will be sending data to the ThingSpeak platform, and that makes your entire project of interface with a hardware gateway system and with a software platform which is a ThingSpeak portal available. You can even utilize it with your institute server, with your own website, maybe with your any Android application. Anywhere you can send data with this ESP module. And it gives you extensive support for all kinds of projects that you want to do with internet based connectivity. As an alternate to this ESP module that we have here, we can also have a combination of Node MCU, which is a combination of Arduino Uno and ESP board. You will find one more chip named as Node MCU, which has lesser number of pins in comparison to your Arduino Uno, but still it gives you a freedom to use gateway as well as microcontroller on the same chip. Other than this, you can also use Raspberry Pi as a gateway module in association with your Arduino board, or it can even work as an independent microcontroller and gateway unit. So in future, possibly you will be learning some new projects with the Raspberry Pi as well. But currently, as a beginner, you can interface it using your simple ESP board to start with your connection. So we are still waiting for data to be transmitted online, and if we just check your ThingSpeak platform, it currently says that last data was sent 7 minutes ago. So we will go back to your COM port settings here and waiting just for a few seconds, and now you can see the update here. I will be just closing the additional windows and waiting for a while, because we have added a delay of 150000 milliseconds, which may be quite longer, but as we have to send an entire data byte from the sensor. And also, if you are using more than one sensor, like 3-4 sensors, which makes your 3-4 different parameters, chances are that you have to increase delay up to 5-6 minutes. That will be completing your packet. So currently we can see data is ready here. It says that it has sent data to the ThingSpeak IP address with a packet size of 60, and this is your complete packet here with field 1 and field 2 getting value of temperature and then humidity. And we can see these recent updates here as well. It says less than a minute ago, and this one is your recent data that we have received, 27.1, and similarly this data 46 as your humidity. So this completes your project of interfacing ESP8266 board with Arduino Uno, and I hope now you must be confident about sending data to the internet, which creates your first base about communicating with internet through things, which are basically a kind of sensor network you can have anywhere in your system. The same concept will be utilizing in a case study further, which will be with air quality monitoring. So you need to use the same concepts over there to send data online. So I hope a good learning from this project, and will be using this knowledge in future as well. Thank you very much for today's session.